again, going off the theme of superheroes. Pretty much, I decided that in order to do this, I could express myself best in poem. And that is what we're going to start today off with. I met a man who told me that we can never actually touch anything, that solidity and tangibility is really just a feeling that tingles through your fingers and lingers in particles of the universe. So when we hold hands or hug or kiss, all we feel is the microscopic repellent of a cloud of electrons moving faster than the speed of light everywhere and nowhere at the same time. So that's what we're talking about today. Basically, it's like the quantum mechanics of superhero powers, so I can teach all of you and persuade you that you can be a superhero too. And basically we're going to talk about how you can time travel and teleport and be faster than a speeding bullet and also fly using basic quantum mechanics skills that we all possess inherently. So that if your clever pickup line on Albert Einstein tanks faster than his first marriage, or if that girl in the bar repels your advances, don't panic. Just blame quantum mechanics. And FYI, Einstein remarried his first cousin, redirecting the energy of his massive intellect into another wormhole, relatively committing incest. Which brings me to my first point. Teleportation! And Albert Einstein, first one, space-time travel. And basically what we're going to be talking about is the Einstein-Rosen bridge. So that wormhole thing, and it's true, he did marry his first cousin, is a fact. Einstein created this theory with Nathan Rosen, that you could space and time travel with two wormholes that were touching on two areas of flat space-time in 1936. And basically the idea was that you could go through one end of a wormhole and pop out at the other end. However, in 1962, John Wheeler, he is another quantum physicist, proved that Einstein had misread on one crucial fact, and that was that there are two kinds of wormholes that you could use in order to travel through time. The first one is called a Lorentzian wormhole, and the second one is called a Euclidean wormhole. And the first one, the L1, we're going to talk about that, is that there are two ways that a wormhole can allow you to travel through space and time, and one is the inter-universe travel, and one is intra-universe travel. So inter-universe basically means you could pop in through a wormhole in, like, say, Earth, and then end up 5,000 miles away, but still within the same universe. While the other theory is intra-universe wormhole travel, which is you pop in through one wormhole and then pop out in a completely different world, a universe that is parallel to ours, but only connected through the Einstein-Rosen bridge, which is why we're talking about it today. So if you ever feel like traveling through space and time, you know, like Back to the Future, then you definitely need to make yourself an Einstein-Rosen bridge in order to do that. Okay, now the second one we're talking about is Heisenberg's theory of, teleportation. Heisenberg's uncertainty theory is the idea that you can never certainly know the location of something while it's moving, and he used that to revolutionize physics and also to get out of a speeding ticket. Basically, it's the idea that if something is here, I cannot say with 100% certainty that these cups are here. And if I leave the room, I'm not 100% certain that those cups would still be there. And it doesn't quite make sense, but according to scientists, and they're much smarter than I am, it does make sense. Especially if something is moving. Because what he was coming at is that when in an atom, there are electrons surrounding it that move up in an electron cloud, like I talked about in the beginning, that pop up in different directions, which appears to be random. And that's saying that because all atoms have this, no atom is static in one location, meaning that atoms can pop in and out of existence at any mean of time. So Max Born was another physicist who related onto this theory and decided that if atoms could do that, that technically means that they wouldn't be static in space or time, and they could pop up anywhere that they chose to be. This is his theory called quantum tunneling, and the hill is an example. An atom normally, for example, we're going to use a wall. If you were going to go up a hill, you could like run up a hill and then run into the rock at the top of the hill, and you could do it over and over again and nothing would happen. But 1 in a trillion times that you would do it, your atoms would actually fuse through the hill and end up on the other side of the hill. And it's statistics, so it's technically a fact, that you could try this 1 trillion times, and at one time out of those trillion times, you would actually phase through a wall. So I encourage you all to run into a wall 1 trillion times, and then one of those times you will phase exactly through it, and you will become a superhero. But keep in mind that in order to do it at 1 trillion times, it would take approximately 1 billion years for that 1 in a trillion chance to happen unless you get very, very lucky. And this means that you're either dead because of old time or because you have a concussion or something. So the next thing we're talking about right now is super speed. And this is the idea of flying faster than a speeding bullet, which according to quantum mechanics is technically possible. Now, currently there is a light speed barrier, and the neutrino experiment happened recently where people actually thought that they had found a particle that moves faster than the speed of light, but this was proven false, and the Icarus project was abandoned, and everyone kind of resigned. It was embarrassing, I guess. But it's this idea that particles of speed of light move the fastest no matter what speed you're going. So imagine you're in a car and you're like going 60 miles an hour and the speed of light is going 100 miles an hour. And that even if you speed up to 80 miles an hour, the car with the atom that's the speed of light will always look like it's going 100 miles an hour. And you'll never be able to pass it, and it'll always look the same no matter where you are. However, scientists at NASA are currently building a warp drive, and I'm not making this up, where they believe that they have found a way to not break the light speed barrier, but to provide a bump so that you can actually move on the level plane of the same as the light speed. I sound like I'm from Star Wars. It's the idea that if the light speed barrier is like the sidewalk and you're just walking on a flat plane, but space-time is constantly expanding in the universe, which is like in an airport if you have one of those like really lazy walkways, I don't know what they're called, but they like basically move you forward even though you really don't need them. It would be like, if that's space-time, then you're walking on that while everything else is simply expanding at the same rate. So if you were to somehow go onto that walkway speed and then bend the area behind you backwards, it would propel you forward on it so that technically you can move faster than the speed of light. And that is called an Alcubierre warp drive. And that is my airport analogy for space-time continuum and breaking through it. And the idea behind it is that if you use this area, you would be able to move faster than the speed of light. And the image to your right is an image of what it would look like if you were actually traveling faster than the speed of light. And I know that in Star Trek they do the one where the stars get all whooshy and like string out, but actually scientists at the University of Limerick discovered that this is what it would actually look like if you're traveling faster than the speed of light. It would all just blend together into that kind of phase. And the last one is flying. So this one goes back to what we were talking about before, how you can never actually touch anything. That whenever you put your hand out, anything you feel is really just the repellent of those microscopic forces in the atoms pushing your hand backwards. This means that technically, if you wanted to go flying, all you would need to do is jump into the ocean, because you would be suspended mid-air without anything holding you. If your body is completely surrounded by water, there's actually a tiny, tiny microscopic space between you and the water, which suspends you in the air so that anyone can be flying if they really wanted. So, you're all superheroes. I commend you all. Welcome to the Justice League. And the last thing I want to talk about was this fun fact, if we go back to teleportation, because I forgot this when I was talking about it. If you've ever seen Star Trek, when people teleport from one area to the other, it's kind of a little scary because in their theory of teleportation, you're not actually being teleported. And I'm going to explain this really quickly. It's the idea that they zapped your electrons and killed you so that they could gather the data from within your atoms. And then basically what they did at the other end is recompose you out of atoms that are currently in the area. So if you think about it, everyone in Star Trek has died multiple times every time they've been teleported up because they were killed immediately when the ray of light hit their atoms. So every time you would teleport, you'd actually be a new person, which is scary, and I never want to do that. So basically, I have discussed how everyone is a superhero, and I would like to conclude with the rest of our poem. Okay. Sorry. Heisenberg balanced theories on the precipice of knowledge proving we could never certainly know the location of where we are at moving, referred to the cups. And he used that to revolutionize physics and then later to get out of a speeding ticket. And Newton understood the gravity of the situation. He could calculate the motion of planets but not the madness of people's emotions, and for him there was no universal attraction of heavenly bodies towards his mass. His belief in God and the alchemy of his golden rod went unused when he passed. He was a virgin. Max Born found that particles could tunnel from point A to point B, and technically speaking, to pass through a wall without touching anything. And he then started a war of the mind with fellow mathematician Christian Klein that Hitler won when he started World War III, or II, but it could be III, because of Einstein's theory of time's like Arnold said, I'll be back, and he was for 2 whole terms as governor. But I prefer to take my cues off screen from the genius of authors who wrote the future they could see. When Asimov questioned what made us human, his bicentennial men pioneered modern robotics as we know it. Burgess believed in the freedom of choice. Ludovico Beethoven, behavior modification. Protecting the voice of those deemed criminal. Orwell warned us of the absolute power of individuals. Propaganda as psychological control over the masses. Huxley cautioned us on the separation of classes. This brave new world has pushed us to the ledge where science and fiction blend together on the edges of overlapping pages reading between the lines. Ideas need